In this video I'm going to be going through the pre-learning quiz for Summer Half Term 1 for Year 7s. It's going to be a very long video. I'm going to go through all 64 questions, but you can skip straight to the question that you need to study by clicking on any of these numbers here, and it will take you to the part of the video where I start explaining the answer to that question. Okay, well, let's begin at question 1. Work out the change from £20 for £12.28. So the answer's already written there, £7.72. How did I get that? It's a subtraction problem because we're talking about the change, and £20 is the number we pay with, and we take away £12.28. Okay, so it starts off looking something like that, but to help us we should put in another decimal point next to the 20 and fill these two columns in with zeros as placeholders. And then 0 take away 8 is 8. No, of course it's not. 0 take away 8 you can't do. So instead you have to go all the way over here, cross that out, make it a 1, and give the 1 that you've just taken to that number there. Then you go over to 10, and you take 1 from 10 and make it 9, and give the 1 that you've just taken, put it there. And then you go next door, and you cross it out, and you make that a 9, and give the 1 that you've just taken and put it there. So now you can do it. 10 take away 8 is 2, 9 take away 2 is 7, decimal point, 9 take away 2 is 7 again, and 1 take away 1 is 0. So you write £7.72 and you remember the pound sign. Half of 47, there's your answer. Two ways of thinking about it. One, look at the, think of the even number that is 1 less than 47, what's that? 46. And the even number 1 more than 47 is 48. Okay, what's half of 46? 23. What's half of 48? 24. So half of 47, which is halfway in between 46 and 48, is going to be halfway in between 23 and 24. And what's that? 23.5, or 23.5. Another way to look at it, or another way to do it, is to just do a straightforward division. 47 divided by 2. 2 into 4 goes 2 times, and 2 into 7 goes 3 times, remainder 1. So you can put the remainder up there, and if you want to leave this as a fraction, you write the fraction line, and then is that number that you're still dividing by. So it's 1 divided by 2, or 1/2. And if you wanted it as a decimal, then you would write a decimal point here, up above, down below, add the 0, put the remainder there, which was 1. 2 into 10 now is 5, and you've got 23.5. Question 3. Write down the measurements that the arrows are pointing to. What can you say? This is easy. That's 50, and you've got 60, 70, 80, 90. Easy. And this one is 260. Very straightforward. Remember to write the units, which I've done here. 15 take away 13 is 2, and 72 divided by 9 is 8. Not sure what to do? Think of it as doing the opposite. If you know that 15 take away something is 2, then you know that 15 take away 2 equals that something, which is 13. And for this one, if you know that 72 divided by a number is 8, then 72 divided by 8 is that number. And of course that must be 9, so that must be 9. Question 5. A quarter of a day, how many hours is that? Well, 1 day equals 24 hours. So to find a quarter, you've got two options. Well, you've got several options, but two that I'm going to start with. One is to divide by 2 and divide by 2 again, and that gets you to 6 hours. Why have I done that? Because dividing by 2 and dividing by 2 is a way of finding half, and then finding half of a half, which is a quarter. The alternative was to just do 24 divided by 4, and that's the same as just finding a quarter straight away, which is 6. Next question, question number 6. Look at the marked angles on the diagram to the right. Shade in the reflex angles only. These are angles that are bigger than 180 but less than 360. Here's one of them, and here's the other one. Name these kites. Name these shapes. This is a kite. It kind of looks like a kite if you imagine it flying off. B is an isosceles trapezium. It's a trapezium because it's got one pair of parallel sides, and these equal sides make it an isosceles trapezium because it's got one pair of equal sides as well. C is a rhombus. All four sides are the same. D is just a plain old trapezium. It's got one pair of parallel sides, and that is all you can really say about it. And the last one is an arrowhead or a delta because it looks like the kind of thing that you would have at the end of an arrow, an arrowhead. Okay. Question 8. Double something equals 62. So it was double 31, and double something equals 63, 31.5. Not sure how to do that. We'll do it the opposite. What's half of 62? And that will tell you what to put here. What's half of 63? And that tells you what to put there. And we did those in question number 2. So one way to think of it is half of 63, 63 divided by 2. 2 into 6 is 3 times. 2 into 3 goes once, remainder 1. Fraction line, and then you write that number there, because that's what you're still dividing the remainder by. And you get 31.5. And if you want that as a decimal, it's 31.5. Name this shape. It's a cuboid. You can tell it's a cuboid because all the dimensions are the same. The width, the height, and the depth, they're all the same. How many vertices does it have? Well, the vertices are the corners. So it's got 4 there that you can see. It's got 3 there that you can see. And then it's got 1 at the back here that you couldn't see, but you can now. So it's got 8 vertices. How many faces? 1, 2, 3, 4, 5, 6. So it's got 6 faces. And how many edges? The edges are the bits that connect 2 faces together. So there's 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. So altogether, that's 12. Look at the parallelogram. Mark on the correct symbols for parallel lines and equal length lines. So to start with, if we put on the parallel lines, we can say that that's parallel to that side. I could write it facing that way, doesn't make any difference. And the other pair of sides are also parallel, so I need to put double arrows. I could have written them pointing down, no problem with that. And in fact, I could have put single arrows on these 2 sides and double on those, it doesn't matter. As long as one pair has single arrows and the other pair has double, you're fine. And then in terms of equal length lines, we've got a side here and a side there that are equal, and then a side here and a side there that are equal. And as before, you could have put the singles up here and the doubles over here. What I wouldn't want to see is the doubles separated like that. That wouldn't be quite right. And with the arrows, I wouldn't want to see the arrows going over the line like that, even if you try putting doubles. Okay, they need to be running in the same direction as the line, like that. And then the equal length lines go like this, something like that. Okay. Question 11. Fill in the check by writing the amount in words. So this part here, 206, and then we've got another part here, 25. How do we know what's going on? This comma here tells you that we're now into the thousands. These are in the thousands. So we would say 206,000. That's the bit I'm highlighting in blue. And 25. That bit there. Okay. Right, a bit of BIDMAS for you. We do the bit in brackets first, so we work that out and you get 6, and and then times it by 7, and you get 42. For these two brackets, what do you need to do? You work them out separately before you do the bit in the middle, which is add. So working them out separately, you find that this is 36, you find that this is 64, and then you add them. 36 plus 64 is 100. Where am I getting all this from? I'm getting it from BIDMAS. So that's the order that you follow when you're calculating problems that have more than one step. So we started with the brackets, there were two pairs of brackets, so we did them, and then we did the addition. And in the last question, we've got 3 brackets 2 plus 5. Right, well, we'll work out what's inside the brackets first, and that is 7. So we've got 7 in the brackets and then 3 on the outside. 3 touching the brackets stands for 3 times whatever's inside the brackets. So then you need to do 3 times 7, which is 21, which is what I've got there. Question 13, 2/3 of this shape. So there are 1, 2, 3, 4, 5, 6 triangles inside that hexagon, and you're asked to shade in 2/3. So 2/3 of 6. Do 6 divided by the bottom times by the top, and you get 4, which is why 4 have been shaded in. Here we've got 1, 2, 3, 4, 5, 6, 7, another lot of 7, another lot of 7. So we've got 21 little squares, and we need to shade in 3/7 of them. Divide by the bottom, so divide 21 by 7, and then times your answer by the top. And what do you get? 9, which is why 9 squares have been shaded in. Estimate the size of this angle. Protractors are not allowed. So here's what I would start by thinking. 90 degrees. If that's 90 degrees, then half of it would look like this. So I've been very generous in giving a range of 30 to 45 degrees, because that to me looks definitely less than 45, but it's never completely possible to tell if you're not using a protractor. So which is why there's a range that's acceptable, and I've said 30 to 45 would be acceptable for that question. True or false? 30 is a factor of 10. It is false. That's because 30 is a multiple of 10. In other words, if you went up in the 10 times table, you would get to 30. Or you could say that 10 is a factor of 30. And that means that you can times 10 by something to equal 30. Question 16. Calculate the answer to this number here. So I've written 283.4, take away 10.56, and I've been very careful to line up the units with the units, the tens with the tens, and the hundreds with the hundreds. What I also did was to fill in a 0 here in this position, so that I don't forget to do 0 take away 6. 0 take away 6 you can't do in this form of subtraction. Of course you can do 0 take away 6, you would get negative 6, but it doesn't work in this kind of column subtraction, so you have to go next door and take one, give the one you've just taken over here, start the subtraction, and so on. I won't continue any further with that. The correct answer was 272.84. Now we're going to put these decimals in order. 0.06, 0.4, 0.04, 0.406, 0.46. Sometimes what I suggest doing is writing out your own little place value table. So this would be units, decimal point, tenths, hundredths, thousandths, and then filling in each of the numbers 0.06, 0.04, and so on until you've completed the table. However, there is an alternative, which is to try and do it by sight. And one way you can help yourself to do it by sight is to have a look quickly at which number has the most number of decimal places, and it's this one. It has 3 decimal places. Now that doesn't mean it's the biggest. Do not make the mistake in thinking that that's the biggest because it's got more numbers. No. The reason why it helps is because if you see that this has got 3 decimal places, then let's give the other numbers 3 decimal places. And what can you add for free? You can add a 0 on the end for free. You can even add 2 zeros on the end for free. You can add as many zeros as you like, in fact, for free. It won't change the size of the number if you put them at the end of a decimal. If you try squeezing in a 0 here, then you will be changing the number. But you can put them at the end of a decimal and you won't have added anything. So now they've all got 3 decimal places. And what I do in my mind is I hide the bits that are all the same in all the numbers. So the bits that are all the same are the 0 decimal point bit, 0 decimal point, 0 decimal point. They're all the same in every number. So if I blank those out in my mind, then what have I got left? I've got what looks like 60, what looks like 400, what looks like 40, what looks like 406, and what looks like 460. This represents 60 thousandths, 400 thousandths, 40 thousandths, 406 thousandths, and 460 thousandths. Okay, so I'm not cheating. I've just in effect multiplied everything by 1,000. Okay, well, it's not going to be too difficult to see which one's the smallest. This one's the smallest, then this one, then this one, then this one, and then this one. But of course when you write the answers, don't write 040, don't write 460, don't write 400, write the decimal number as it was in the question. So 0.04 is the smallest, 0.46 is the biggest. We've got to use 2 of these cards in question 18 to make a fraction that is less than a half. Fraction that is less than a half. So let's have a look at some fractions that do equal a half. 4 over 8, 5 over 10, even, although this isn't really an acceptable one, 4.5 over 9. What do you notice? You notice that all the fractions that are equivalent to a half have a numerator that is half of the denominator. Okay, well, with that knowledge in mind, let's keep this one. You wouldn't really write a fraction with that because that's a decimal, which is a kind of fraction itself in the side of a fraction. That's not acceptable maths. You would find another way to do it. But it helps us to see what the halfway fraction would be if the denominator was 9. So any numerator that's smaller than 4.5, in this case, if it's over 9, will give us a fraction that's less than a half. So I could have 1 over 9, I could have 2 over 9, I could have 3 over 9, I could have 4 over 9. They're all fractions with 9 as a denominator that are less than a half. But of course we've only got these cards to play with, 7, 6, 3, 5 or 9. So I've already got the 9 card in play. There's no 4, so I can't have that one. There's no 2, so I can't have that one. There's no 1, so I can't have that one. So 3/9 is one of the possible options. Okay, which is why I've written it here. Now imagine that 7 was the denominator of choice. Halfway would be 3.5. That's equivalent to 1/2. So less than a half is where we're going to get a numerator that's smaller than 3.5. So 3 over 7, 2 over 7, or 1 over 7. But we've got no 1 card to play with, we've got no 2 card to play with. So these won't do. 3 over 7 is another option that's smaller than a half. Now why aren't there any others? You're probably thinking. We've had a denominator of 7, we've had a denominator of 9. Why couldn't we have a denominator of 6 or 5? Okay, well let's try a denominator of 6. Here's 6, what's halfway? 3. So you can have 2 over 6 is less than half, or you can have 1 over 6, which is less than half. But there's no 1 in the cards above, there's no 2 in the cards above. So that didn't work. And if 6 isn't going to work, then 5 isn't going to work either. Halfway would be 2.5. So what does that give you? 2 over 5 or 1 over 5 as fractions smaller than a half. But 1 and 2, as I've said before, are not in the list of cards. So forget that. There's nothing else. It's only 3/7 or 3/9 in this case. Question 19. Simplify these expressions. 3c plus 2 plus 2c take away 4. What do you need to do? You need to get the terms that have the same variable together, and if they don't have a variable like this one and this one, then you get them together. So I'll get these. Notice how I've included the plus sign to the left of the 2c. That plus goes with the 2c. So I'll rewrite that, 3c plus 2c. And then I'm going to push this constant and this constant over to here. Plus 2, the plus goes with the number to the right, and take away 4. Now we're starting to get somewhere. 3c plus 2c is 5c, and plus 2 take away 4. That's like going forwards 2 steps, but then backwards 4 steps. So what's that the same as? The same as going backwards 2 steps, or taking away 2. So we get 5c take away 2 as our simplified expression. And then here we've got 5d plus 2k take away 3d plus 4k. Get the d's together, take away 3d. Get the k's together and rewrite 5d take away 3d, which came from here. Add 2d. Not 2d. Add 2k. Add 4k. What have you got? You've got 2d and adding 2 and then adding 4 is the same as adding 6. So you're adding 6k. Right, that's that done as well. 24 equals 280 take away something. Okay, what can this be? Well, something must equal 280 take away 24, and that must have been 256 then, is what you get when you do 280 take away 24. So in which case this number here is 256. Change this improper fraction into a mixed number, 18 over 5. So you ask yourself, how many times does 5 go into the top number? How many times does the bottom number go into the top number? The reason why is because if something is cut into fifths, then it takes 5 fifths to make one whole. And we've got 18 fifths to play with. So we can make one whole out of 18 fifths. We can make another whole out of 18 fifths. So far we've only used 10 fifths. We can make yet another whole, and that has only taken 15 fifths so far. We can't make one more whole though. We've used up 15 and we've only got 3 left. So we've then got 3 left which we can shade in like this. So that's 3 wholes and 3 fifths. 1, 2, 3 wholes, and here there's 3 fifths. So how did I do that, and how could you do that without drawing a diagram? You ask yourself, how many times does the bottom number go into the top number? 3, that's your whole. It goes in 3 whole times. And what's left? What's the remainder? 3. Okay, so 3 and 3 fifths. Ronaldo scored in 18 out of 20 football matches. Based on this information, in what percentage of matches does Ronaldo scored? I'll start by writing that as a fraction. 18 out of 20. That's a very good average. So, 18 out of 20, we want it as a percentage. What do I know about percentages? I know that they are all fractions out of 100. And what do I know about equivalent fractions? I know that if I multiply the top and the bottom by the same number, or divide the top and the bottom by the same number, then I can create a brand new equivalent fraction. Okay, well, I want to turn 20 into 100 using multiplication. And then whatever I do to the bottom, I'm going to do to the top, because that's how you find an equivalent fraction. So 20 times 5 makes 100. I will do the same to the top. 18 times 5 is 90, and that can be written as 90 with the percent sign. 23. This is again about equivalent fractions. The first one's been done for you. 4/7 links to 20 over 35. Why is that? Because the top and the bottom have been linked by multiplying the top and the bottom by the same number, which is 5. And then I look at the other pairs of fractions. 11 over 12, that can only go with 121 over 132, because here top and bottom have both been multiplied by the same number, which is 11. If you look at the other fractions that still remain, that one's gone. So these are the fractions that maybe could have joined with 11 over 12. You can't times 11 by a number to get 40 and multiply it by that same number to do turn 12 into 80. That doesn't work, so they're not equivalent. And you can't do it with 20 over 55. You couldn't do it with 15 over 60 either. The only one you could do it with was that one. 4 over 11, times them both by 5, you get 20 over 55. It's the only one that it works with. 1 over 4, times them both by 15, and you get 15 over 60. And then 1/2 is equivalent to 40 over 80, because they've both been times by 40. Question 24. Here is a shape. Here it is. Write an expression for the perimeter, which is the distance around the outside. So that means we need to add up all the dimensions, all the side lengths. N plus 1. Where's that from? That's from right here. Then another add n plus 1, which comes from this one here. Then add the next side, which is 2n. Then add the next side, which is n plus 1. Then add, guess what, 3n, and then add 2n. Add 3n, add 2n. So picking out just the n's to start with, n plus n plus 2n plus n plus 3n plus 2n. You add those all together, you get 10n, and then adding the constants together, add 1, add 1, add 1, that's the same as add 3. So your perimeter in the form of an algebraic expression is 10n plus 3. Calculate the fraction of the quantity below and leave your answer as a mixed number. Okay, if you can see that 17 won't divide by 9 without a remainder, so in other words, if you can see that 9 doesn't go into 17 nicely, then my recommendation is that instead of dividing first, you divide second. Okay, instead of dividing first, you divide second, and instead of multiplying second, you multiply first. What do I mean by that? Well, if you were finding a fraction, say 4/9 of 18, then you could do 18 divided by 9 and then times by 4. But you're not finding 4/9 of 18, you're finding 4/9 of 17, and 17 doesn't divide by 9 very nicely. So instead, do the multiplying by 4 first, and then divide by 9. Okay, 4 times 17 is 68, and then you need to divide by 9, so you can write that like this. Okay, getting closer, but it does ask for a mixed number. So 68 divided by 9, how many whole lots of 9 can we get into 68? We can get in 7 whole lots of 9, and then there would be 5 left over. 7 times 9 is 63, remember? So then there's 5 left over to make it up to 68. So 7 and 5/9. A CD holds several songs on it. You can work out how long the disc plays in seconds using this formula. Playing time equals 150t, where t is the number of songs. And this means that you need to do 150 times t, because they've been written next to each other. So if t is 10, then you simply do 150 times 10, and there's your answer. And if t is 9, then you simply do 150 times 9, and there's the answer. Really, it is that simple. Question 27. Masumi has worked out the answer to an expression. 12 plus 14 squared divided by 2 equals She says 16. Is she correct, yes or no? Explain the answer. The answer is no, because in fact the answer should have been 20. Why is that? Because of BIDMAS. So if you've got 12 plus 4 squared divided by 2, what would you do first? You would do the index number, which is this bit here, and that's 16. What have you got left? 12 plus 16 divided by 2. What do you do next? You do division next. 16 divided by 2 is 8. What have you got left? 12 plus. So what are you going to do now? You're going to finish off with the addition. 12 plus 8 is 20. Okay? So if you follow the order of BIDMAS, which is what you should do if you've ever got a calculation that has more than one operation in the middle, then you follow the BIDMAS order, and what you should have got is 20. So in a perfect answer, you would say whether it's yes or no, and then you would explain what the answer should have been and demonstrate why it should have been that. Y equals 4x minus 2 is an equation. Yes, it is. Not denying that. What is the value of y when x equals 2? Y equals 4x minus 2. This stands for 4 times x. So y equals 4 times 2. Where does this 2 come from? It comes from here in the question. Take away 2. So 4 times 2 is 8, and then take away 2 gives you 6. Y equals 6. Which expression has the greatest value when z equals 10? So if z is 10, then we would do 10 take away 2, which is 8. We would do 4 times 10, which is 40. We do 2 times 10, and then add 12, which is 32. And here we would do 3 times 10, and then take away 18, which is 12. So which one's the biggest? This one. 40 is bigger than all of the others. So the expression that is greatest when z equals 10 is 4z. I should say that don't just go for the biggest coefficient. That won't necessarily be the case, because if I'd said 3z plus 11, then when you work out what 3z plus 11 is, you get 41, which would have been bigger than that. So in which case you would have been fooled into thinking that 4z gives you the biggest one just because the coefficient is bigger, when in this case this whole expression needs to be worked out and you would have got a big one. Okay, so the secret isn't, or there isn't a secret to this, you actually just have to work each one out and see which one's biggest. Okay, 30, matching each of these, not too difficult. The mystery number doubled, that's got to be 2 lots of n. The mystery number squared, that's got to be n squared. The mystery number halved, n divided by 2. Now it's a little bit harder. The mystery number multiplied by 6 and added to 2. Mystery number, call it n, multiplied by 6 and then add 2. Okay, so that goes with this one. And the reason why it goes with that one and not that one is because it's slightly different. Here, the mystery number has 2 added to it and then is multiplied by 6. So you get that. Question 31. Simplify these expressions. 5a times 2. 5a times 2. 5a stands for 5 times a, and we still need to times it by 2. So what can you do? You can do a bit of rearranging. You can move the 2 over to where the a is, move the 2, swap them around so that we change the order. You can do that with multiplication because you can multiply in any order you like. 5 times 2, well, we can shorten that to 10, and then you need to times it by a, and you can shorten 10 times a to 10a. Okay, that was probably very straightforward. If you're happy with that, then the simple way to remember it is to multiply the numbers together. That gives you 10, and then multiply it by whatever variables you've got. So we can apply that here. 9g times 4g times the numbers together, the coefficients, and you get 36. Where's that from? 9 times 4. Ah, yes, 36. Now we still need to do g times g. So times g times g. But you can shorten that to 36 times g squared. And you can shorten that to 36g squared. Okay? So we can just bring that a bit closer. 36g squared. Which is what we've got here. Okay, question 32. Bill is B years old, Don is D years old. Write expressions for someone who is twice as old as Bill. If Bill is B years old, then someone who's twice as old as Bill is going to be Bill times 2. So you can write that as 2b, 2 times b, b plus b, or b times 2. Okay. Write an expression for someone who is the sum of Bill's and Don's ages. Sum means the answer you get when you add a couple of numbers together. So presumably Bill plus Don would look like this. You could also write it as Don plus Bill. Simplify this fraction as far as possible, or write it in its lowest terms. 297 over 396. Big numbers, not ones that we are familiar with in terms of our times tables, but we have some strategies up our sleeve. We know when we're simplifying, we need to look for a number that they both divide by. So I'm looking for a number that goes into 297 and goes into 396. The ones I recommend trying are dividing by 2. Do they both divide by 2? Divide by 3. Do they both divide by 3? Try dividing by 5. Try dividing by 7. Try dividing by 11. And if you're still really stuck, try dividing by 13 or dividing by 17. You will I would have thought that the large number of proportion of questions that you get, we are told to simplify, would be covered by trying one of these 7 options. And sure enough, if you try dividing by 3, you get 99 over 99 over 132. So now you've got 99 and 132. What do they both divide by? They both divide by 11. 99 divided by 11 is 9. 132 divided by 11 is 12. What do these both divide by? They both divide by 3 as well. What do you get? 3/4. Okay, you could have done that all in one step if you had recognised that they are both in the 99 times table. So you could have divided both of them by 99 and you've gone straight to 3/4. Not saying it was obvious, but it's possible. At KSA, 5/6 of all scholars have read the entire Cherub series. If there are 120 KSA scholars, how many have read the entire Cherub series? So we're looking to find 5/6 of 120. Divide by the bottom, times by the top, if you can. Otherwise, times by the top and then divide by the bottom. And when you do that, you get 100. Give your answer to these questions in their simplest form. What fraction of 20 centimetres is 15 centimetres? So it's something, a fraction of, or fraction out of 20 centimetres. It's out of 20. It's 15 out of 20. But it asks for the fraction in its simplest form. So you divide top and bottom by the biggest number you can think of, which is 5. You get 3/4. You try dividing that by the biggest number that you can think of. You can only think of dividing by 1, so in that case we've written it in the simplest form. Next one. What fraction of 4 pounds is 2 pounds? So it's a fraction out of 4 pounds, and it says 2 pounds out of 4 pounds. So very simply, we've created a fraction, 2 out of 4, but we're asked to simplify it, So we think of a number that they both divide by, and what do you get? Well, you can think of they both divide by 2. When you do that, you get 1/2, and that is fully simplified. Write 72% as a fraction in its simplest form. Well, if I start by writing 72% as a fraction, I would write 72 over 100, and then cancelling that down, I would look for numbers that they both divide by. So they both divide by 2, which gives you then 36 over 50. These both divide by 2, which gives you 18 over 25. And I can't think of any other common factor of 18 and 25 apart from 1, so in which case I've simplified it as far as I can. 70 take away something is 59. It must have been 11 that we had to take away from 70 to make 59. Some people, when they remember what they need to do with solving equations, they think, right, I've got to do the opposite. So instead of taking away, they think, okay, I'll do 70 add 59. You know, and in some equations, doing the opposite like that would work. 70 add 59, that's 129. Okay, so we're saying that this is 129, are we? 70 take away 129 is 59. Something's not right there, and it's at that point when you do the check that something should say in your mind, not quite right, I need to go back and see what I've done wrong. And if you let common sense prevail, you will realise that you need to take away a relatively small number to reach 59. Here n must have been 18, so that when you add it onto 22 you get 40. Here b must have been 8, so that when you do 6 times 8 you get 48. And here k must have been 20, so that when you divide it by 5 you get 4. This is really easy, I won't spend long here. Translate this equation into English. Various ways you could say it. One that I've suggested is you do take 7 times u away from 52 and you get 108. Now take this sentence, which is in English, and turn that into an algebraic equation. F times 8, then take away 50 is equal to 30. But of course you can write this in a more economical way. You could write 8f, and that would be preferred. Multiply out the brackets. Another way of that you might see that is if it says expand the brackets. It means the same thing. Expand the brackets. So what do? You times each of the terms on the inside of the bracket, so the x and the plus 7, you times them each by the number on the outside. So 2 times x and 2 times and 7. 2 times x is 2x, and 2 times add 7 is the same as adding 14. So that's it. We've expanded the brackets. You multiply the term on the outside by each of the terms on the inside. And then we've got 6 brackets 2x take away 1, so do 6 times 2x, and then do 6 times take away 1, and you get 12x take away 6. The classic mistake that I see a lot of people making is to do the first one and not the second one. So they would do 6 times 2x and happily write 12x and then just copy this down. But unfortunately that's not correct. You need to multiply each of the terms by the number on the outside. So 3 brackets 2a plus something, close brackets, equals 6a plus 9. Here the brackets have already been expanded or multiplied out. How do you go from 3 times 2a to get 6a? Yeah, you just do 3 times 2a, you get 6a. So what have you got to times 3 by to make 9? Well, you just times it by 3. 3 times 3 makes 9. Okay, what needs to be on the outside of the brackets so that if you times it by 2e, you get 10e, and if you take away 6 by that same number, you get take away 30. In other words, look, 2e times what makes 10e. Take away 6 times what makes take away 30? Must have been 5, right? So in which case our missing number outside the brackets is 5. 40. Here's a rectangle, yep. Write an expression for the area, which is the amount of space that the shape covers. So to find the area of a rectangle, you know that you need to times the length by the width. So you need to do 2f times 7f. Give your answer in the simplest form. So this is not the final answer. We need to do 2 times 7 times f times f, and you get 14 times f squared, but the simplest form is 14f squared. Not a multiplication in sign in sight. 41. Think of a mystery number, p, and multiply it by 8. Write an expression. So here's p, times it by 8. So you could write p times 8, you could write 8p, you could write 8 times p. This is the preferred one. The answer, after I've multiplied by 8, is 40. Write an equation. Great. 8p equals 40. Easy. Solve your equation to find the value of p. So if you know that 8p equals 40, you can divide both sides by 8, and you get p equals 5. Solve the equation 6c, take away 7 equals 11. We'll start by adding 7 to both sides, and then rewriting what I've got left. I've got the equal sign, I've got 6c, and I've got 18. 6 equals 18, so divide both sides by 6, and you get c equals 3. 43. A Porsche 911 should cost £62,450. However, Mr. Reddy wants it with an iPod dock so that he can play his cheesy driving tunes. The shop charges an extra 1/100th for the iPod dock. In other words, an extra 1/100th of the price. What is the total price of the Porsche with the iPod dock? So, you need to find 1/100th of the price. 1/100th of the price, you do the price divided by 100. £624.50 for the iPod dock. That is not the final answer. It asks for the total price of the Porsche with the iPod dock. So this is the price of the Porsche. This is the price of the iPod dock. You add them to find the total, and you get £63,074.50. 44. Calculate 9/20ths, take away 2/5. Taking away fractions with different denominators is not difficult. All you need to do is think of a denominator that they both have in common. 20 and 5. So you think of the 20 times table, you think of the 5 times table. Where do they meet? Ideally for the first time. The 20 times table meets the 5 times table at the number 20 itself. Yes, 20 times 1 is 20, and 5 times 4 is 20, so they both meet at 20. Seeing as this one's already out of 20, you can keep it that way, 9. But this one we're turning into something out of 20, so times the bottom by 4, times the top by 4, and it becomes take away 8. Then you've got 9 take away 8 is 1 out of 20. There we go. 45. Bart has been asked by Mrs. Crabapple to solve the equation 3x plus 6 equals 18. So what would we do if we were trying to solve it? Don't even look at Bart to start with, because he might be wrong. You decide what you should do. Take away 6 from both sides. 3x equals 12. Divide both sides by 3. What do you get? X equals 4. He says that x equals 2. So clearly he's done something wrong. So we say no, and then we have a look at what he's done. 3x plus 6. He's then simplified it to 9x. Hold on a second. You can't add 3x and 6 like that. You can't simplify them like that. That's not possible. And yet he thinks he can. He's called it 9x. Well, once he's done that, I can see why he says x equals 2, but he should never have said that 3x plus 6 is 9x to start with. So that's where he went wrong. So we can write an explanation like that, or to that effect. Bart added 2 terms that he's not supposed to. He should have taken away 6 from both sides, not added 3x and 6 together. So it's that kind of an answer that you want to be giving, a full explanation of what he did wrong and what he should have done. 46. Calculate the volume of this cuboid, remember the units. So to find the volume, you do the height times the width times the depth. Height times width times depth. So that's 7 times 5 times 12. 7 times 5 is 35. 35 times 12, not so easy. So instead, why don't I do 5 times 12, which is 60, and then do 7 times 60 in my head. 7 times 6 is 42, times by that 10, 420 centimetres cubed, because you're trying to find the volume. If you put squared, that's wrong. If you just put centimetres, that's wrong. If you just put 420, that's wrong. It has to be 420 centimetres cubed, or even better, I prefer people to say cubic centimetres, so that they don't get confused with people who are trying to say 420 centimetres and then cube it, as in 420 times 420 times 420. That's not what we mean. We mean 420 cubic centimetres, so try getting into the habit of saying it like that. 47. Find the area of this triangle. So the area of a triangle is found by doing half of the base times the height, or base times height divided by 2. So this is the base. I know it's at the top, but it's the base because it's perpendicular 90 degrees to the height, and that's what you're looking for. So it's 9 times the height, which is 10. What? Why isn't the height 11? Is this not the height? No, it is not the height. The height has to be at 90 degrees to the base, and you see that right angle? That tells me that this number 10 is at 90 degrees to the base. 11, however, is not at 90 degrees, it's at some other angle which looks a bit like 60. Okay. So, that was just me saying do the base times the height, but you now need to divide it by 2. So 90 times 10 is 45, divide that by 2. No, 90 times 10 is 9 times 10 is 90, but then when you divide it by 2 you get 45. Sorry, I was a step ahead of myself. And then the units square centimetres. Yeah, not centimetres squared, but square centimetres. So that people don't get confused if you say 45 centimetres squared and they think you mean 45 centimetres times 45 centimetres. If you say square centimetres, people know that you're talking about that. Try substituting some values into the expressions below and decide whether each is always, sometimes, or never true. So here we've got x plus x equals 2x. Is that always true? Or is it sometimes true? Or is it never true? Basically, try substituting x for any old number. Let's say 8. 8 plus 8. And over here we would have to do 2 times 8. And what do you get? 8 plus 8 is 16. 2 times 8 is 16. Yep, they're equal to each other. So that worked. What about if we changed 8 for, I don't know, let's say 5. 5 add 5 equals 2 times 5. Yep, 10 over there, 10 over there. So yeah, that works too. You know what, I think this is going to always be true, because if I have a number and I add it to itself, which is what this is saying, that's the same as doing 2 times that number. So yeah, it's always true, isn't it? Right, what about this one? 2x equals x squared. Okay, well, start with calling x 4. So then we would do 2 times 4. And over here we would do 4 squared. 2 times 4 is 8. 4 squared is 16. Ah, they're not equal to each other. So in that case, we found a time when they're not equal to each other. So we know that it's not always true. it's either sometimes true or it's never true. Okay, well let's see if we can find a time when 2x does equal x squared. What about if I said let x be 2? Then I would have to do 2 times 2 here, and I'd have to do 2 squared there. 2 times 2 is 4. 2 squared is also 4. Aha! So we've found a time when, if x is 2, 2x will equal x squared. So in that case, we can't now say that it's never true, because clearly we found a time when it is true at least once. It's true when x is 2. So in that case we say it's sometimes true. It's not always true, it's not never true, it's sometimes true. X take away 4 equals 4 take away x. Okay, substitute x for different numbers. Let's say that x was 10. 10 take away 4. Oh, this should have been, keep the 4 here. And change that to 10. Got rid of the wrong one. Okay, so 10 take away 4 is 6. 4 take away 10 is negative 6. They do not equal each other. So we've found that it's not always true. Can we find a time when it is true though? What about if x was 4? Then we've got 4 take away 4 equals 4. 4 take away 4 is 0. 4 take away 4 is obviously the same thing. So yes, 0 equals 0. Ooh. So they do equal each other. So in that case, it's not never true. It's not always true, it's not never true, it is sometimes true. We found a time when it was true, because if x is 4 then it works. We found a time when it wasn't true, for example, when x was 10. So it must only be sometimes true. 49. Work out the answer and leave the fraction in its lowest terms. 1/3 plus 2/8 take away 1/6. We look for a common denominator of thirds, eighths and sixths. And what do you get? You think of a times table, they're all in the 24 times table. We're adding and then taking away. So 1/3 times top and bottom by 8. Why? Because you need to turn 3 into 24 by times it by 8. So what do you get? 8 times 2/8 into something that makes 24 times top and bottom by 3. Why? Because it's 8 times 3 that makes 24, so therefore do the same to the top. You get 6. And turning 1/6 into something out of 24, well, I know I need to times 6 by 4, so I need to times the top by 4 as well. And you get 4. Okay, what have we got then? We've got 8 24ths plus 6 24ths take away 4 24ths, which is what I've got written up here. 8 plus 6 is 14, take away 4 is 10. Then it says give the fraction in lowest terms. It would be a shame to get as far as this, which did take a little while, and not read the question properly and simplify. Okay, well 10 over 12 simplifies to 10 over 24 simplifies to 5 over 12, because you can divide top and bottom by 2. You cannot divide 5 and 12 by anything apart from 1, so that is it in simplest form, or in lowest terms. Lowest terms means the same as, aka simplest form, also known as simplest form. Think of a number p and multiply it by 9, okay, 9 times p, and then subtract 15. Okay, easy. So that simplifies to 9p take away 15. And the answer after I've multiplied by 9 and then subtracted 15 is 102. Write an equation involving p. So we had 9p take away 15, that was our expression up here, and now we're told it equals 102, which is why I've written the equation there. Solve your equation to find the value of p. 9p take away 15 equals 102. Add 15 to both sides. 0, 117. 9p equals 117. Not sure what the value of p is? Divide both sides by 9. 117 divided by 9. 9 into 1 doesn't go. 9 into 11 goes once, remainder 2. 9 into 27 goes 3 times. So p must be 13. p equals 13. Solve these equations by multiplying out the brackets first. Okay, 2 times s and 2 times plus 4 gives you 2s plus 8 equals 16, and then you simplify that in the way that you normally do. Take away 8 from both sides, you get 2s equals 8, divide both sides by 2, you get s equals 4. Multiply out these brackets, so 3 times t, 3 times take away 1, you get 3t take away 3 equals 18, and then you simplify, then you solve and you get t equals 7 eventually. 60 people were surveyed on their favourite sports. The results are shown in the pie chart on the right. How many people preferred netball? So first things first, identify which is the netball sector. Netball is in red, and it's this one here. If your page has been printed in black and white, then what you need to do is look at the first one. They're always written in order. Soccer will always be the one that starts at 12 o'clock and then starts going round. So that's always the first one. Then the second one will be the second segment. The third one will be the third segment. And the last one will be the last segment. So that's why netball is the last in this list, and it corresponds to the last segment, starting at 12 o'clock going round. Okay, so after all that, what we've worked out so far is that netball represents 30%. Okay, so we want to find 30% of all the people. That's 30% of 60 people. They're the ones who liked netball. Okay, not so sure how I do this just yet, but I do know a little bit about percentages and fractions. So I'm going to turn 30% into a fraction. I'm going to turn that into a simplified fraction, 3/10. And now I'm going to find 3/10 of 60. Okay, 3/10 of 60 I can do. 60 divided by 10 times by 3 gives you 18. There you go. This bit must represent 18 people. In that case, that 30% also represents 18 people, and so does that one. 18 add 18 add 18, that's 54. So this little guy here, that must represent 6 people, because it makes it up to 60. Is that right? 10% of 60? Yeah, it's 6. Seems to work, so there we go. 18 is your answer. Find the area of this parallelogram. The area of a what's going on with my spelling? The area of a parallelogram can be found by doing base times the vertical height. What is the vertical height? It's the height that is at 90 degrees to the base. Not this one. That is just there to fool you. It's a bit of extra information to see whether you realise that actually the only bit of information that you need is that. So we do the base 14 times the vertical height, which is 6. What do you get? 84. Remember the units, square centimetres. The classic mistake that people often make is that they think they need to divide by 2. You do not. You divide by 2 specifically for triangles and trapeziums. Okay, then there'll be some dividing by 2 involved. But for parallelograms, including squares, rectangles, rhombuses, parallelograms, you don't divide by 2. It's just base times height. Simplify and solve these equations. So get the h's together. 5h take away 2h gives you 3h. Get the constants together. The add 11 and the take away 4. That gives you add 7. And it all equals 16, remember? So then you go ahead and solve it by taking away 7 from both sides. and that eventually works out to be h equals 3. Over here, get your r's squareds together. No, there is only one r squared. Okay, so happy with that. Get your r's together, 2r and take away 2r. Oh look, they cancel each other out. If you add 2r and then take away 2r, what are you left with? Nothing, right? No r. In which case you don't even bother writing that, because well, it just equals 0, right? So they cancel each other out, they're gone. And then get all your constants together, take away 5. Oh, it's the only one. Brilliant. Easy. So it's just r squared take away 5. And that equals 31. Remember to write out your new equation once you've simplified it and solve it. Add 5 to both sides. Equals 36. So what have you got left? You've got r squared equals 36. Okay, square root both sides. And what do you get? R equals 18, yeah? Because you just divide by 2. No. No, please do not just divide by 2 to find the square root. You have to think of the number that when you times by itself will give you the number here. What is that? It's 6. Okay, because 6 times 6 equals 36. That's why 6 is the square root. Okay. 55. Lisa's expanding brackets. She writes 2 brackets 3b plus 3 equals 5b plus 5. Okay, we'll have a go at what this should be if you're trying to expand the brackets. You would do 2 times 3b, you do 2 times 3, you get 6b plus 6. But she says it's 5b plus 5. So she is not right. Now in a model example you would explain why she's wrong. What has she done wrong? And you would say what it should be. So above I've said, because Lisa added 2 to each of the terms inside the brackets when she should have multiplied by 2, the correct answer would be 6b plus 6. That's how to give a model answer. 56. Work out 12 and 1/6 take away 7 and 2/9. My preferred way of doing this is to turn these into top heavy fractions. So 12 and 1/6, that is 73 over 6, and turn 7 and 2/9 into a top heavy fraction, and that is 65 over 9. Now find a common denominator, the lowest common denominator preferably, for 6 and 9. What is that? It's 18. Okay, 6 and 9 both go into 18, that's the smallest number they both go into. So to turn 6 into 18, times it by 3, that means you'll times that one by 3, and to turn 9 into 18, you times them both. Well, you times 9 by 2, so you have to times 65 by 2. Once you've done 73 times 3, you get 219. How did I do that? I did 3 times 70, which gives you 210, and 3 times 3, which gives you 9. Add the two together, you get 219. And then we're taking away 65 times 2, which is 130. 219 take away 100 is 119. 119 take away 30 is 89. So this equals 89 over 18. And you can leave it like that, or you can turn it into a mixed number. And 18 times by 2 is 36, times by 2 again is 72. So it goes in 4 times, that's 4 holes, and what's left over? 17. So it's 4 and 17 over 18. That's if you want to leave your answer as a mixed number, but the question doesn't ask you to, so you could just leave it as an improper fraction. Put these fractions in order of size, starting with the smallest. Okay, I've got the answers there. How did I get that? So we've got 3/4, we've got a number out of 16, we've got a number out of 8, we've got a number out of 2. Give them all a common denominator. They all go into 16. 4, 16, 8 and 2 all go into 16. This one's already out of 16. 3/4. To turn that into something out of 16, times the bottom by 4, times the top by 4, so you get 12. 5/8 times the bottom by 2, so you times the top by 2 and you get 10. And for this one, you times the bottom by 8, so you times the top by 8. What have you got? 4 fractions, all out of 16. You can now compare the numerators. This one's the smallest, 8/16, which was 1/2. This is the next smallest, which was 5/8. This is the next smallest, which was 3/4. And this is the largest, which was 13/16. And then maybe just write a comma in between them. Okay. A formula is used in physics. Yep, this is a true formula. This is not made up. S equals half of brackets u plus v times t. It's really simple. If S is, find S if u is 2, v is 8, and t is 2. S equals 1/2 brackets. U we swap for 2, and v we swap for 8. Close brackets. T, which stands for times t, or times, in this case, 2. When you work that out, you work out the brackets first. 2 plus 8 is 10, so then you've got half of 10, and then times by 2 equals 10. Okay, work out the missing number. 1/5 of something equals 14. Okay, working this backwards. I was thinking of a number. I divided it by 5 and times the answer by 1, and I got the answer 14. So I'm thinking of a number. I divided it by 5, I times by 1, and out came 14. So working it backwards then, we will need to do divide by 1 and then times by 5. 14 divided by 1 is 14. 14 times by 5 is 70. So the answer here is 70. Does that work? Let's check it. 70 divided by 5 is 14. 14 times 1 is 14. So yes, it does work. Okay. Here we have a triangle. It says that the angles are x, 2x, and x plus 40. And it says write an equation in terms of x. I know that the angles inside a triangle add up to 180. So I'm going to write an equation where I'm adding the 3 angles together and making it equal to 180. So we've got this angle, A, plus x plus 40, which is the angle at B, plus 2x, which is the angle at C. Then if you simplify that, the x plus the 2x, that's 4x plus 40. So you've got 4x plus 40. And I said it equal to 180 because the angles inside a triangle add up to 180. And then you solve it for the next part. 4x plus 40 is 180. Take away 40 from both sides. You get 4x equals 140. Divide both sides by 4. And you finally find that x equals 35. If you know that x equals 35, then this must be 35, that angle there, so that's why I've written A equals 35. B, which is x plus 40, is 35, therefore plus 40, which is 75, which is why I've written B equals 75. And this angle here stands for 2 times 35, so that's 70. It's really straightforward actually, isn't it? Looks hard to start with. Expand these expressions. X brackets x plus 6. So x times x gives you x squared. X times add 6 gives you add 6x. 3b times 6 gives you 18b. 3b times take away b gives you take away 3b squared. Now we need to do 10c times by d, times by take away 4c, and times by add 7. So 10c times d, 10cd. 10c times take away 4c is take away 40c squared, and then 10c times by 7 gives you add 70c. Question 62. Work out the value of these expressions when d equals 2, e equals 4 and f equals 5. So if d is 2, you need to do 2 squared plus 3. 2 squared is 4, and then add 3, which is 7. E squared over 8. That stands for e times by itself divided by 8, which is 4 squared divided by 8. 4 squared is 16, then you need to divide it by 8, which is 2. And then 2d squared f. So if d is 2, we need to do 2 times 2 squared, and if f is 5, then we need to do times 5. So work out the squared bit first, and that's 4, and then do 2 times 4 times 5, which equals 40. That's what we've got there. A square has side lengths in centimetres of 2y. So it's a square, so we know that they're all 2y. I'll fill those in because that might help. A triangle has side lengths in centimetres of 3y take away 1, 2y plus 5, and 4y take away 7. Here's the square, here's the triangle. Form an equation in terms of y. What? Hold on, how can we do that? Because there's a little bit more of the question that we didn't read. The perimeters of the square and the triangle are equal. Perimeter, distance around the outside. So that's, for the square, it's 2y plus 2y plus 2y, but all of that can just be shortened to 8y. So that's for the square, and it equals the perimeter of the triangle, which is 3y take away 1 plus 2y plus 5 plus 4y take away 7. If you simplify all of that, what do you get? You get 3y plus 2y plus 4y, which is 9y, and then if you do take away 1 plus 5 take away 7, that's the same as taking away 3. You get 9y take away 3. That is the perimeter of the triangle. Okay, so there's an equation. 8y equals 9y take away 3. And then you solve it. 8y equals 9y take away 3. Take away the smaller number of y's from both sides. You get 0 there. You get y here. So we now have 0 equals y take away 3. Add 3 to both sides, and you get 3 equals y. Or y equals 3. And if you know that y equals 3, you can use that to find the side lengths of the triangle. The side AB, that is the side from A to B, so it means 3y take away 1. If we've just discovered that y equals 3, then we need to do 3 times 3, which is 9, take away 1, which is 8. So I've written 8. The side BC is the side from B to C, and that's 2y plus 5, so that bit is 6, and then we have to add 5, and you get 11. There's your answer, 11. And finally, AC is from here to here, so that's 4y take away 7. That means this bit is 12, we take away 7, we get 5. And I've written the answer there. Solve these equations. 7x take away 12 equals 4x plus 3. We've got an unknown on both sides. To solve that, we take away the smaller number, the smaller coefficient next to the unknown. And that in this case is 4, because 4 is a smaller coefficient than 7. So take away 4x from both sides. You get 3x over here and 0 there. Write out what you've got left. We've got 3x take away 12 on the left hand side equals 3. So then you add 12 to both sides. That's 0, that's 15. Then you've got 3x equals 15. divide both sides by 3 and you get x equals 5. X equals 5. For this one, 10x plus 3 equals 7x plus 9. So if you take away 7x from both sides, because that's the smaller coefficient, you get 3x there, you get 0 there. Write out what you've got left. 3x plus 3 equals 9. Take away 3 from both sides, you get 3x equals 6, and you find that x equals 2. Okay, that was the last question on the paper. Feel free to click on the link to take you back to the menu and try a different question. Thanks for watching. Bye.